so we're back here. So let's go through some quick practice problems. Just something should be fairly easy. So we'll start with 9.32 on page 417. So this question is asking, we have 583 female workers. So female workers. In the survey, we're asked how many hours they worked in the previous week. And we had the mean is equal to 37 with a standard deviation of 15.1. Does this suggest that the population mean work week for females is significantly different from 40 hours? So is this different than 40 hours? Because that's the standard work week, right? All right, so let's think about how we would answer this. So part A. Part A is asking us, identify the relevant variable and the parameter. So the variable that we're looking at is the number of hours worked by females. And the parameter that we're interested in, so the parameter, because this is quantitative, is going to be mean hours worked. So, and this will be symbolized with U. So, part B. Asking, state the, stating the null in alternative hypotheses. And so, let's see. So this question is only asking for significant differences. It does not give a direction on that. So the null right here is that the mean is equal to 40 hours per work week. And the alternative, because we do not state a direction on this, is saying that the average hours for women does not equal 40. Again, there's no direction here. Part C. Reporting and interpreting the p-value for the test statistic significance. So first thing we got to figure out is the standard error, which is the standard deviation. So S divided by the square root of n. And then we plug that in. So if we figured this out, right, so this is going to be, what is that, 15.1 divided by the square root of 583. And then we would plug this into our formula. And so what we're basically trying to figure out, right, is that women in the sample work 40 hours. We divide that by, we're subtracting that from 40 because that's the hypothesized mean. We would put in 15.1 divided by the square root of 583. And if we calculated this out, we would get a score of negative 4.8. And this p-value, because it's really, because this t-score is really big, is basically 0, right? Really small. So we showed that this is pretty different, right? So part D is asking us, explaining how to make a decision for the significance level at 0.01. Definitely bigger than 0.01. So we would reject the null hypothesis. And say the mean working week is different than 40 hours. Now, important little note here, right? So this is only statistical significance, right? And you may be asking yourself, practically, practically, is this significant? So really, is 3 hours that big of a deal? And so that's something that, a researcher has to answer, or you as a decision maker, so a researcher or a decision maker, have to make. That cannot be made for you. You have to do that yourself. So keep in mind, right, that you might look at these and say, wow, even though there is a statistical difference, the statistical difference does not always going to equal something that is practical significance. So just something to keep in mind, kind of hold on, and just keep that in your back pocket for later. We'll talk a little bit more about that later. So next problem, we'll go back to our green color, and we'll do 9.33. And this question is asking, we got Facebook friends. Many students brag they have more than 100 friends on Facebook. Wow. For a class project in 2014, a group of students asked a random sample of 13 students. So 13 people. And about their number of friends, and got the following data, right? So we have 55, we have 130, we have 210, 75, 80, 205, 20, 130, 150, 50, 270, 110, and another 110. So is there strong evidence that the mean number of friends for the student population who use Facebook is larger than 100? Okay. So first thing it's going to ask is what are we trying to look at here? What exactly are we trying to solve? So the first thing that we're looking for, right? So the variable is number of Facebook friends. The parameter is mean number of friends. Part B is asking us, what are the null and alternative hypotheses? So the null is going to be that the average number of friends is 100. The alternative hypothesis, right, recall that there's actually a direction placed on this. And so what this hypothesis is saying is that the average is greater than 100, right? So that part is super key. Part C. Part C is asking us find and interpret the test stat value. So keep in mind that the t-score is going to be equal to x bar minus the hypothesized mean divided by the standard error. And the standard error, of course, is s divided by the square root of n. So we would, if we substituted this, it would be s divided by the square root of n. That would be solved first. So what if we evaluated this? So this average of those numbers up there, if we did that, should be 122.7 minus the hypothesized mean number of friends divided by the standard error, which is 71.8, divided by the square root of 13 people. And this would be 1.14. So what we would find is that, another way of saying this is that the sample mean, x bar, is 1.14 standard errors away from the null from null. So if we go back and look at this for a one-sided t-score, this p-value is going to be 138. In this case, this is pretty small. And so we would not reject the null hypothesis. So that's what we conclude. So basically, we wouldn't say based off of these data. So based off of these data, we cannot say that the average number of friends is different from 100. Note that I'm being very careful with my language, right? So we're not saying that, we're not accepting that 100 is the correct number. We're failing to say that it actually is different. So we don't have enough data to suggest that this is different than 100. This does not mean 100 is correct. It means we failed to reject it. Again, that is a very important distinction. It is not the same thing as accepting it. And that's something that we'll kind of talk about a little bit later. So hopefully that made sense. And we can move on and talk about this a little bit later. So I'll see you guys in the next video.